Okay, so let's talk about area. Let's recap what we've learned, okay? Area is what? What is the formula for area?
Base times height.
Area is equal to base times height. Thank you, Bailey. Thank you. Thank you. I love how active you are and how informed you are. Okay? Area is base times height, right? It is literally the inside, and again, we mentioned this before, it is like putting tiles on a flat surface and then counting how many pieces of tile you need to complete this square. The number of tiles, you could say it's 1 inch by 1 inch, 1 foot by 1 foot, 1 yard by 1 yard. It just depends on what you're talking about, how big this 1 by 1 tile has to be, okay? It's a way of like picturing how many pieces you need to fill in that void, that square that you're looking at, okay? That's how you find the area of a square or a rectangle. Your base times your height will give you that answer. But now, what happens if instead of a square, I give you, and again, I am an excellent artist, as you can see. You can see that I have no flaws when it comes to art. What is that? A cube, right? And a cube has what? A cube has a base. It has an area. It has also what we used to refer to as the height, right? Because if you stand up this piece of paper, you have a base and you have a height, right? But what if I laid this piece of paper flat on the ground, okay? And then I said, okay, this would be my height, right? But in a 3D shape, instead of calling it height, let's just call it length, okay? Let's call it length. Put a little curly L here, okay? So now you have your base, still a base, but now you have the length, okay? You see that? That would be this here. You see that? If you guys catch this on, everything I throw at you after this, you'll pick it up right away. Because it's literally the same thing for every shape. Any three-dimensional shape, you start with the same thing. An area is a two-dimensional thing where there's only a base and a height. Once you get into three-dimensional shapes, this is still important. You still need to know what this is, but now you're gonna take this piece of paper and you're literally gonna lay it flat on the ground. So you're looking at this space here. You can see this is your paper right here. Okay, do we have another color I can do? Alright, how do you tap on it? Go ahead. Yeah, you do it better than I can. Okay, let's say call it put green. Okay, now, this is this part right here, so trace that paper right there. There you go. You see that? Perfect. Thank you. Thank you very much. That is this here. Flat on the ground. Can you see that? You can see what I'm saying? Okay? Now, all we need to know now is what? Now we need to find out what the height of this cube is. Okay? So let me say this. If this is the new height, what would the formula be for this? Okay, and again, we don't call this is called area. When it's two-dimensional, we find the area. This is two-dimensional in the sense that if I want to know how much carpet I need to buy, it's a flat surface. You use area for that. But if you want to fill this room full of $100 bills or whatever, sand, you would need to know the volume, right? Because now you're talking about a substance that is going to rise as you keep dumping more of it in, okay? Or like a gallon of water. Do you ever go to your mom's and fill up the gallon of water, or how do you guys drink water? Right? You don't go to the hose and drink it, right? You have to go buy a gallon of water. That is volume, Okay, you're using liquid to fill something. The same thing here. We're gonna find out how much we can fit inside this cube. Okay? And to do that, we still need to know this part, but we also need to know how tall this thing is. So, volume is equal to base times height, but your base in this formula is going to be these two combined. So you first have to know your area, and then once you know your area, that now becomes your new base. Does that make sense? Your base is no longer just one-dimensional. Your base is now the area of this flat piece of paper, which includes the length here. So if I had 5 here as my length, and I had 20, if I had 2 here as my base, then I would say, okay, 5 times 2, and then times my height. Say my height was 10. Okay? It would be volume is equal to 5 times 2, which is 10, my area, times the height, which is 10. So it would be 100. If I'm calling these in inches, so my answer would be volume, my volume would be, it would be 100 inches, not squared, this is squared. What do we call it when it's 3? We call it cubed. Why cubed? Because there are 3 dimensions. This way, and this way. It's cubed. Okay? Does that make sense? Alright, let's give you guys one of these, and if you guys can solve it, we're done. Here's one. Tell me what the volume is for this cube. Okay, let's call this 5, 4, and 2. Okay, and like I said, volume is equal to your base times your height. Who wants to do it? Figure it out. Okay, so your base is going to be length times base. This is length times base, so that's 4 times 2. 4 times 2 is what? So then your base is 8 times, what is your height? Your height is 5. So then your answer should be 40. See that? Another way you could see it, if it makes more sense to you guys, it just depends on how the formula is written. But another way you could look at this, and this is probably the more practical approach. Let's try this. Volume is equal to base times length times height. That's what volume is. Your base times your length times your height. That's your volume for a cube. Okay? Yes, you want to time these two. You want to get this first, and then you multiply it by the height. Okay? Technically, you could do all 3 of them in any way, but train yourself to do this first because there will be other shapes that are not going to look like that. There's going to be pyramids that are 3-dimensional. Like one? that are gonna be three-dimensional, and those might be a little trickier, so you wanna keep that, make sure you identify those two first. Okay,